are going to just talk about how to go the other direction. Some people, just depends on you. Some people think this is easier. Some people think formula writing is easier. I think they're both the same. They're just a bunch of directions. Now, if you will notice, though, there's a lot more words on this page, right? And that's not meaning that it's harder. It's just a little bit more wordy to explain the process of finding names. And will everyone look at this box right here? That one's tricky, but if you'll just pay attention and do it with me over and over, it's not hard at all. Nothing is really that hard if you'll just follow the directions specifically. Just real quick before we do anything, do we know that the absolute value of a negative number just means you're making it positive? All right, because we are going to use that. And we've sort of been using that all along. Can you explain to your lab partner when a negative number has just been made a positive number in the last 2 or 3 days? All right, so it was when we did what? The drop and swap. So like CA, CL, this was a -1, but we just said, hey, it's a 1. We would never put a negative there. We okay with that? So when we do this process of flipping a negative into a value, don't stress about it. It's just to make things so they're not negative, but we just use math terms. So let's go ahead and attack these. I can't remember. So it looks like the practice ones I did will be the ones on the inside. So turn to page 19, the first page 19. And you guys are getting this better than my 2 other classes by a mile. I think it's mostly because you pay attention. I say mostly because there's someone that doesn't pay attention very often. No names. But mostly we pay attention. So here we go. You would use this side to find the name. How would you know that? There you go, because it says right here. Use this side to find the name, and then in bold it says start. It gives you an arrow right there. If your naming schemata, once again, does not have those arrows that go all the way across, make them go all the way across so you realize that the yeses and nos are there. All right, so just go with me here. CA and O is the first one. So does the compound contain more than one type of atom? Yes. If it didn't, it would just say Ca. And that would be easy. You would call that calcium and move on with your life. Does the compound have metallic and non-metallic atoms? Yes. And I had someone yesterday teaching their lab partner in exasperation where the metals and non-metals are. I don't remember what hour. But they were like, hey, everything on the side of that little staircase over here is a metal, right? And over here are your non-metals. This is something that you absolutely should know by now, is where the metals and non-metals are. So we had Ca over here, we had O, so the answer would be yes. All right, then we come down. We'll come down. Are there more than 2? This seems to confuse kids once in a while. Are there more than 2 kinds of atoms? No. This is a Ca and an O. If this were yes, it'd be like CaCO3. 1, 2, 3 types of atoms. So this question is saying, is there a polyatomic ion? And no, it was just Ca and O, correct? Thank you. So no. Is the first atom a member of family 1 or 2? Yeah, it is. So you come down, and these are one of the easier boxes. Name the first atom as an element, and the second one ending in IDE. So what's the first atom? Calcium. Whoops. And what's oxygen ending in IDE? Oxide. We cut the middle out very often. If you wrote oxygenide on your test, I wouldn't mark it wrong. I would laugh when I graded it, because we've heard of carbon dioxide before, iron oxide, probably never carbon oxygen ion. All right, that wasn't super hard, was it? Okay, let's come back and do the next one. Come on. So the next one is BaSO4. So let's just attack that one. Definitely more than one thing, right? Does it have metals and nonmetals? Yes. Everyone put your finger on there so I know you're following along with me, please. Are there more than two kinds this time? Yes, there are. There's Ba, there's S, and O. That's three things. That's more than two. Is the first atom a member of any of those? Yeah. Barium is in family 2. So we go up, and it says, name the first atom as an element, then identify the polyatomic group from the chart and write its name second. So here we go. What's the metal called? Barium. I want this one to go away. And then what's SO4? Sulfate. Barium sulfate. Some of you are very good learners in here, and I love your brain, so keep going without me. You don't have to have me hold you through this process. But a lot of you do need to ride on my back, so let's do it together. But if you need to, just go ahead and go on. So we are doing HClO4. Does it contain more than one kind of atom? Yes, it does. Does it have metal and nonmetals? That one's a no. Hydrogen's a nonmetal, chlorine's a nonmetal, oxygen's a nonmetal, right? All right. Does it start with the letters of NH4? No. Does it start with an H? Yes, it does. My favorite box. Name the acid. You don't have to think, you just have to find. So you find HClO4, and it's perchloric acid, correct? No. It's sort of a bad acid, but not really that bad. No. The only acid you use in cooking is called vinegar. And vinegar, we'll say, is like a 3 on the bad scale. This is probably like a 6 or 7. But it's like, okay, yes, if you ingest it, it will kill you. But no one's just chugging acid, I hope. All right, next we have CuC2H3O2. That's going to take us to a new box. And please pay attention on this one. So does it contain more than one? Yeah. Metal and nonmetals. Yes. Will you look just right here? If the first atom is a metal, the answer is always yes. If the first atom is a nonmetal, then the answer is always no. So you could rewrite that. Is the first atom a metal? It's the same question. It will have the same answer. All right. Now, this one, does it have more than 2 types of atoms? Yeah, it has a lot of them, right? We go over, is copper a member of any of those things? Definitely not. So we're in the box of death, which really, my friends, is not that bad if you just take it one bite at a time. So it says, multiply the charge of the polyatomic ion by how many units there are. So let me rewrite this. It's Cu C2H3O2. Now, this is tricky. This is our polyatomic ion right here. How many of them are there? Nope. No. No. There's one of them. There is this thing is one thing, and there are one of them. If there was more than one, what would we see in the thing? No. parentheses. So if there's no parentheses, the answer is always 1. It's tricky because you're like, hey, there's 2, or there's 5, or there's 7. No. C2H3O2 is one thing. It's called acetate. And in this compound, there's one of them. Who's with me on that there's one? If there's more than one, you would see parentheses. Okay, so here we go. I'm going to stay on this. Let me back up a few things to make this prettier. Come on. Come back. All right. So the instructions, look in that box. It says multiply the charge of the polyatomic ion by how many there are. So we got to go, we got to go to the front and find acetate. So the very top left. It's your first one, I think. All right, so what's its charge? -1. How many did we just say there were? We just said there's 1. So look, and you're like, why am I doing this? It's just 1, but it's not always that way. So you take -1, and the instructions that we would have read in that box is multiply the charge by how many units there are, meaning that number. And then it says to do what? Divide, all right, sorry. Take the absolute value of that and divide it by the number of what? First atoms. So how many coppers are there? There's just 1. Now this was a buttload of work to just get the number 1, right? It's not always going to be a 1 because this isn't always a 1, that's not always a 1, and that's not always a 1. So the odds of it always being 1 is just crazy. It's not going to happen very often. All right, now the instructions say to take that number and convert it to a Roman numeral to follow the name of the metal. So what is Cu? Copper. And what was this? 1 acetate. Copper 1 acetate is the name of that. Now, there's a lot of steps there, but individually they're not that bad. Let's do another one just like that. So we'll go down to, let me look at something real quick. Number 9. Is that what you said? Number 9. Number 9 is the exact same box. So will you try to do number 9 on your own real quick? If you don't know CO, it's cobalt. Well, he did work all night, so I would bet he is also. All right, here we go. This one was CONO2. Is that right? All right, so I told you it was the same box. So the first thing you need to do is multiply the charge of this by how many there are of those. So you have to find NO2 on your polyatomic ion sheet, whatever. And it is a what charge? -1. So you take -1 and multiply it by 2 because of that 2 right there. And then you take the absolute value of that number and you divide it by the number of cobalt atoms, which again is just a 1. So what does that equal? 2. What does that 2 become? 2 I's. And that follows the name of the metal. Cobalt 2. And then nitrite. Who had that right? As I looked around, most of you had it right, so that's good. Let's do one more from that box. What a letdown. I want to find one specifically that has more than one of the first things. Number 30 will take you to this same box on the back. Number 30. Feel guilty, just realize, oh, hey, that makes sense. I won't do that again. This is Hg, was there a number? 2SO4. Same box, and a lot of kids will make the same mistake, and I'm used to it. I've taught for 15 years. So you take the charge of SO4, which is -2, correct? And you multiply it by the number of the polyatomic ions. How many are there? There's the deal. There is 1 of them. The 4 belongs to SO4. I'm not kidding you. I'd be laughing if I was. We said if there's more than one, what would you find? Parentheses. Were there parentheses? No, there were not. So here we go. -2 times 1. Take the absolute value and divide it by the number of first atoms, which is a 2. That's a 1. So mercury, 1. Sulfate. That would be the answer to that one. Okay, let's do a couple more, and then we'll have some freedom. Oh, I miss freedom. He came that first week of school. Remember those days? Was it just the first day? It was a good first. It was a good first day, though. I enjoyed. Do you know? I got to shut this off. Let's go to number 6. Number 6 is different than what we've done, so let's review that one together. Number 6. So first off, does it contain more than one? Yes, that's pretty much always going to be yes. There's one of them in your homework that doesn't. So here we go. Yes, does it have metal and nonmetals? No. N is a nonmetal, H is a nonmetal, O is a nonmetal, H is a nonmetal. They're all nonmetals. Three of them are gases. All right, then we go that way. Is NH4 first? Yes, I love these. We go straight over, and it just says, write the name ammonium, and then either the element or the polyatomic ion next. So is OH just one element, or is it a polyatomic ion? It is polyatomic, thank you. So here we go. You write ammonium, hydroxide. Where did I find hydroxide? On the front page, on the polyatomic ions. It's the most common one we use, is OH. So some of you probably already have that memorized. All right, let's find one that sends us to a different spot. Here we go. Number 12. Let's look at number 12. It'll be the last one we do together, then I'll just let you work. So number 12. Come back here. Number 12, it has more than one. Does it have metal and nonmetals? No, they're both on the right side. Does it start with NH4? No. Does it start with hydrogen? No. Are there more than one of the first atoms? No. So here we go. Name the first atom as an element. So we're phosphorus, right? What number was this? Number 12, right? So we're phosphorus. The second one ending in "ide," but you must have a prefix to tell you how many of the second ones there are. What's the prefix for 3? Tri. So the answer to number 12 is phosphorus triiodide. Triiodide is fine. Not too bad, right? Okay. There's another one like those if you want to do that right now. Not very many. Number 16 is just like that. Now, number 16 is sort of annoying because if you look at 16, NO2 is a polyatomic ion. But NO2 is also a compound. And the difference in 16, you'll see NO2 and there's no charge. Do you see that? So that means it's not a polyatomic ion. It has to be charged. On the front, if you look at NO2, it has a minus, and we call it nitrite. 16 will just follow the normal naming rules. and you'll see what that is. And you'll have heard of that before, most likely, if you've had your teeth taken out. All right, I'm going to stop this. You work together with your lab partner and ask me if you have any questions. I can help you out.